Hi, my name is Felipe Jornada. I'm a graduate student in physics at Berkeley, and I work with Professor Stephen Louis to try to explain and understand new materials. I'm a theoretical physicist, and we try to use more calculations to try to understand and predict properties of new materials. What I really like about this group and this environment about here is all the history, what has happened so far, and what is the future that we have. One of the grandfathers of our research is Professor Marvin Cohen. So Professor Cohen basically did a lot of research on silicon, and he tried to explain and understand this element. And silicon is the base of all the computer, basically from the calculator to your personal computer, your mobile phone, to all the supercomputers. And the kind of research that he developed during the 70s and the 80s, there was a lot of theoretical calculations and simulations. He really understood how the electrons work in the systems, and that is really important and was really important for all the years to develop all the computers. And working with Professor Stephen Louis, which was actually advised by Professor Cohen, I'm working right now with graphene. And graphene, which is a 2D system like this sheet here, has a huge potential to be this future silicon. So I mean, silicon is a nice element, it is the building block of the computer, but you can't just squeeze it. You can make smaller and smaller computers. There's a limit if you want to continue using silicon. And graphene, which is this material here, has excellent properties. You can basically do very powerful computers using less energy, more environmentally friendly, and is also pretty strong. And there are a lot of interesting properties. So what we do here is we try to explain the basic physics behind this material. So this is a representation of graphene. Graphene is a 2D material. It is like a sheet of paper. And actually graphene you can find basically in a regular pencil. So in a pencil what you have is actually graphite. But graphite is just a bunch of those sheets here. So each of these black points here represent one carbon atom. In case you don't know, carbon is basically the element of life, and you are basically water and carbon. And these tubes here, they represent the bondings between all these atoms here. So the nice thing is that you can really go to pretty small devices if you use graphene. And actually graphene is also pretty strong. Because of this geometry here, you can really try to bend and stretch, and it's really hard to break this structure here. They're actually even trying to use graphene for touchscreens, because graphene is transparent and graphene is actually a really good conductor. And this looks like science fiction, but actually in 2004 the scientists first were able to really experimentally build one of these sheets, and that is why they got the Nobel Prize later. My research was actually on the light properties of graphene, how it interacts with light. And that was really interesting, and a lot of applications to use graphene in those devices. And the interesting thing about this kind of research is that it's a really long-term research. So if you go back to Professor Cohen, the kind of research that he did during the 70s, it really took 30, maybe 40 years just so that we can have all these high-tech industries that are all based in silicon. Now imagine the same thing about graphene. It's not from the day to the night that we suddenly have this high technology industries based on graphene. And for this reason, it is pretty important to invest in basic science. We really have to understand this, and we must have a long-term goal of having industry and having researchers involved in that. And it's really not only, I think, that science is something that you can buy and you can just copy science that is being developed somewhere else. If you really invest in universities, you have people that are working and they have the culture and knowledge of this material. So there's really a lot of interplay in universities between knowledge and industry. And this is also something that you can only have if you really invest in education and university and research in your country. That is why this kind of investment is really important, and the future generations are going to appreciate any investment that you do continuously right now.